Hi guys, welcome to today's lesson on quadrilaterals, properties of trapezoids and kites. So we'll start off with some definitions. First of all, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So down here we have an example of what a trapezoid would look like. We've got two bases and two legs. So in defining a trapezoid, we talk about that has exactly one pair of parallel sides, and that pair of parallel sides are my bases. So the bases will be the parallel sides, the legs are the segments joining my two bases together. Our second vocabulary word would be isosceles trapezoid. An isosceles trapezoid is a trapezoid with congruent legs. So this right here is an example of our isosceles triangle on the right here, isosceles trapezoid, I'm sorry, on the right. So we have our one pair of parallel sides that are opposite from each other, and then we notice our two legs right here, which are congruent to each other. So just like an isosceles triangle that has two pairs of congruent sides, an isosceles trapezoid has a pair of congruent legs. So we'll go ahead and start talking about some properties of isosceles trapezoids. Property number one is base angles of an isosceles trapezoid. If a trapezoid is isosceles, then each pair of base angles is going to be congruent. So this is an isosceles trapezoid where both legs are congruent. Then the base angles are going to be congruent to each other. Now the base angles in an isosceles trapezoid are defined by the angles formed by the base, which this would be a base, and this would be a base. So the angles formed by the base and the leg. And remember, the legs are going to be my congruent sides right here. So the base angles in this case would be, these two angles right here would be congruent to each other. And then these two angles up here would also be congruent to each other. So there's two sets of base angles, and both sets of base angles are congruent to each other. The second property about base angles of an isosceles trapezoid is that if a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. So this works both ways. It's like the converse of property number one. So if an trapezoid is an isosceles trapezoid, then it has congruent base angles. And then the converse of that would be property two, which is where if a trapezoid has a pair of congruent base angles, then we can say it's an isosceles trapezoid. Last property of an isosceles trapezoid is that if a trapezoid is isosceles, then it has a pair of congruent diagonals. And so what this means is that if I have, my isosceles trapezoid, so if this is my isosceles trapezoid, trapezoid ABCD, then the diagonals would be congruent to each other. So one diagonal would be AC, the other one would be BD, and what we'd be saying here is that diagonal AC would be congruent to BD. And again, this is true and only in isosceles trapezoids. So for example number one, we're going to use some of the properties we just talked about and find the angle measurements in this isosceles trapezoid. So again, we know it's isosceles because we're given that AB and CD are congruent to each other. So, and then we're also given that AD is parallel to BC, making it a trapezoid, and then the legs congruent makes it an isosceles trapezoid. So we're given angle B, which is 135 degrees. So we already know that. And we want to go ahead and find the other three angles, angles A, C, and D. Now, based on one of the properties we just talked about, that isosceles trapezoids have congruent base angles. So BC is one of my bases, and this angle right here, angle B, is 135 degrees. The other base angle right here would be angle C, and those are going to be congruent to each other. So angle C is also going to be 135 degrees. Now, the other two angles we want to find are both angle A and angle D, and the way we're going to find this is we're going to use properties of parallel lines. If I extend AD and BC as parallel lines, and then I think of the green line right here, AB, as a transversal, angle B right there, which is 135 degrees, would be related to this angle up here, which would be angle A, and those would be consecutive interior angles because they're both on the same side of the transversal and they're inside the two parallel lines. And the relationship between consecutive interior angles is that they are supplementary. So to find the measure of angle A, we're going to go ahead and subtract 135 from 180, which is going to give me 45 degrees. And again, because we know this is an isosceles trapezoid, angle A and angle D are going to be congruent because they're both base angles. So angle D will also be 45 degrees. Now, one way to double check this would be to add up all four angles, and it's a quadrilateral, so they should all add up to 360. We know 45 and 45 is going to be 90, 135 and 135 is going to be 270, and 270 plus 90 is going to be 360 degrees, so that's just one way we can check our answer. The next topic we're going to talk about is what's something called a midsegment in a trapezoid. And a midsegment is exactly what it sounds like. It is a segment that connects midpoints of the legs of my trapezoid. So if I have in this trapezoid up here, trapezoid ABCD, M is a midpoint of AD, and N is the midpoint of BC. If I connect those two segments, I get segment MN, which is considered the midsegment. The midsegment theorem for trapezoid says the midsegment of a trapezoid is parallel to each base, and its length is half the sum of the lengths of the bases. So if I want to find the measure of a midsegment, it's going to equal 1/2 times base 1 plus base 2. So in example number 2, we're going to go ahead and apply our midsegment theorem. So given this trapezoid, PQRS, and we're given that M is a midpoint of PS, and we're given that N is the midpoint of QR. So that makes MN a midsegment. To find the length of MN, we would just take half times base 1, which is 16, plus base 2, which is 9, and 16 and 9 is going to be 25, and half of that's going to be 12.5, and this is going to be in inches. So the length of MN is going to be 12.5 inches. And again, we just did 1/2 times base 1 plus base 2. All right, next we're going to talk about a kite as our next quadrilateral. Kite is going to be a quadrilateral that has two pairs of consecutive congruent sides. So in this diagram that you have right here, you've got two sides that are blue and two sides that are green. Now they're color-coded this way to show you the pairs of sides that are congruent to each other. Now the big thing we want to focus on in the definition here are the words consecutive congruent sides, which means there are two sides that are next to each other that are going to be congruent to each other. So you see the green sides are next to each other, they're touching, and they're congruent to each other. The blue sides are also congruent to each other, and they're touching as well, so they're next to each other. So we have two pairs of consecutive congruent sides, which is not, in the parallelogram we have two pairs of opposite sides congruent, but in a kite the sides are going to be consecutive, so next to each other. Now we've got two quick properties of a kite. First property has to do with the diagonals of a kite. And if a quadrilateral is a kite, then its diagonals are going to be perpendicular. So in this diagram right here, AC would be one diagonal, BD would be the other diagonal, and they would intersect to form a right angle in the middle there. So diagonals of a kite are perpendicular to each other. Property number 2 of a kite is that if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent to each other. So they only have one pair of opposite angles congruent. Again, if in this diagram, if you look at it, we see it's going to be angle A and angle C. And the angles that are going to be congruent to each other are going to be the angles that are formed by the non-congruent sides. So we see that BC and DC are not congruent to each other, so they form angle C. And BA and DA are not congruent to each other, and they form angle A. Therefore, angles A and C are my congruent angles. In example 3, we're going to apply property 2 for the kite, showing that we have exactly one pair of opposite angles congruent. So we're given two angles. 70 is the measure of angle Q, and angle S is 88 degrees. We don't know what the measures of angle R and angle T are, and we want to find the measure of angle T. But based on the property that we just talked about, we know that we have exactly one pair of opposite angles that are congruent to each other. And it's going to be the angles formed by the non-congruent sides. So if we look at ST right here and QT, they are not congruent to each other. So this would be one of my angles. The other angle will be QR and SR, which are not congruent to each other. So angle R and angle T are going to be my congruent angles. So if you don't know what these angles are, we'll just go ahead and call them X. But if angle T is X, angle R is also going to be X. We know that all quadrilaterals add up to 360 degrees. So I'm going to take all my angles, X plus the two angles that I do know, 70 and 88 and set them equal to 360 degrees. So combined like terms, x plus x is 2x. 70 and 88 is going to be 158 equal to 360. We're going to subtract 158 from both sides. This will cancel. 2x is going to equal 202. Divide both sides by 2, and x is going to equal 101. So the measure of angle t, which is what I'm looking for, is equal to 101 degrees. Remember to go ahead and try the You Try Nows right now. If you have questions, make sure you write them on the side. And good luck, and may the force be with you.